Okay, geometric transformations. Here we go. Translations, reflections and shears predominantly today. We'll see how we go. We might go further, we might not go that far. I'll do the rest tomorrow and then you'll get plenty of time to practice these things. It's a bit tricky because if you go into your exercise in the textbook, you'll find that they kind of mix them up a bit. So, but I don't really want to teach them all to you this afternoon. So starting with reflections, I've just summarised on here the process and then where it comes from, and it's going to be pretty short scale, but that's where we're going. So starting with a simple reflection, there's my first example. I can't move I'm going to zoom out a little tiny bit more. There we go. So we've got a couple of notes. First of all, P, the first point is our original, P dash is our image. We talked about that last lesson. And so we have P and P dash. Hopefully you can see here that P has been reflected over the x-axis to get P dash, which means that point X has gone to X dash and Y has gone to Y dash. But in this case, and so you can see the X dash, Y dash notation over here. In this case, point X has gone to X. If you reflect over the x-axis, X doesn't change. Y changes, Y becomes negative Y. And if Y was already negative, then Y becomes negative of a negative number, which becomes positive. So that still works, even if you've got a value that's under the x-axis. And so you can see I've written here in orange, X goes to X and Y goes to negative Y. That's what I've done. I've done this process for all of our transformations we're going to talk about over the next couple of days. My question is, what goes inside that 2 by 2 matrix to make X, Y go to X negative Y? Any takers? 1, 0, 0, negative 1, I will take. So that is almost the identity. It's the identity that takes the diagonal of 1s take xy to xy, but then having that second one of negative 1 changes the y to negative y. Everybody happy with that? So this matrix here is the reflection over x. Our second one here, part B, reflection in the y-axis. I hope again this is not too hard. So if we're reflecting in the y-axis, we are taking x to negative x and y to y. You can see that on there. Again, it's just negating the x value. And what will the matrix be this time?
Negative 1.
Just negative 1? 0, 0, 1, cool. Negative 1, 0, 0, 1. So there we go, that's pretty easy. You'll need to know these matrices or the premise of these matrices. It's going to be a lot to memorise, but if you understand where you're taking a point to another point, then it's quite easy to recall. So it's that depth of understanding will help you with memorising this. The last one is taking, or there's two more, but there's two versions of this one, taking a point from xy across the line y equals x. So you're reflecting across this line that's on a 45-degree angle over to here, or from here over to here. And because of our definition of the line, y equals x, it means that the y value is going to the x value and the x value is going to the y value. How do we do that in matrix form? Say it again, sir? 0, 1, 1, 0. So we just reverse that diagonal. Is that all right? Cool. And then the last one, which is reflecting over the line y equals negative x. Anybody want to tell me how we might do that? Negative 0. Negative 0. 0, negative 1. Negative 1, 0. Okay? If you have just 0, 1, negative 1, 0, that still will provide a transformation, but it doesn't do that directly related reflection. So it will reflect x across to negative y, but then y will just go to x, not negative x. So it will take y to whatever this value is here. And you'll get a point somewhere down there.
Which one's the image in C?
C is the reflection across the line y equals x.
Yeah, but the dash should be on top.
Oh, there's no... Oh,
Yeah, it'll be the bottom one.
yeah.
Not from X, Y.
Yeah, you're right. Yep, this one here that's been reversed. Any questions? So that's reflections across the line. Now we're going to talk about dilations. And again, we'll start with just X dilations, Y dilations, and then combine dilations and talk about what they look like. So I'm going to shoot down. Oh, here's an example actually. If the point P2, -3 is reflected across the line Y equals X, determine the image coordinate P' through matrix multiplication and sketch. Any takers? What's P going to be? -3, 2 is right. But it has asked us to do it through matrix multiplication. So 2, -3 is here. That's P. And it's being reflected over the line Y equals X, which is here. And so P' will be about there. And P' will be equal to 0, 1, 1, 0 times by 2, -3. And that comes out as 0 plus -3, and then 2 plus 0, which is equal to -3, 2, which we knew anyway. So this transformational stuff here, this reflection stuff, when you take some time to think about what the reflection over Y equals X equals and what it means, you don't really need that matrix to multiply by, because it makes really clear sense. But when we get to our composition of transformations, that'll become really important, because when we compose transformations, it means that we might be doing 2 or 3 things at the same time. And we can combine matrices by multiplying those matrices together, in the right order, of course. Here's dilation.